Here in example 9, it states that multiple occurrences of the variable appear within the equation. See, we're asked to solve this equation for x, but we have an x here and we have an x here. That doesn't have an x and that doesn't have an x. So how are we going to get just x equals whatever it's supposed to be equal to? So the first step on tackling a problem like this is to gather up the terms that have an x on one side and the terms that don't have an x on the other side. Okay, so we are going to accomplish that by, here's one way to do it, subtracting cx from both sides. I'm going to squeeze that in right here, and subtracting 2y from both sides. Okay, after we get some things cleaned up here, that's going to leave us in our problem with 3x minus cx equals d minus 2y. Okay, now we are asked to solve for x, and with this on the left hand side we have an x in common with both of those terms, so we're going to pull out that x and we are going to write the leftovers. Basically what we did here is we factored out the common factor of x from both of these terms. If you would use the distributive property to run the x back through, you can see we didn't change anything, we just factored it. Okay, let's bring down the right hand side, d minus 2y. Now, we're trying to get x by itself, and right now it's being multiplied by this quantity, so what we need to do is divide both sides by 3 minus c, that quantity. Now, when we do that, what happens is the 3 minus c's reduce, just leaving us with what we were going for, x on the left-hand side. So x is d minus 2y divided by that quantity 3 minus c. Now we will go ahead and sum up the key concepts in each of the sections, and you have these on your notes by filling in the blank. So let's fill in the blank with the best response. The first one says an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0, is called a blank equation in one variable. Think about what might go in there. These are linear equations in one variable. A linear equation is also called a blank degree equation, because the degree of the variable is 1. The degree of the variable is 1 in a linear equation, so we call these first degree equations. If you have in an equation, if you have a 2, we'll call that a second degree equation. And then we could have a third degree equation if you have an x cubed and so forth. Number 3, a blank to an equation is the value of the variable that makes the equation a true statement. Think about what would go in there. The answer here should be solution. A solution to an equation is the value of the variable that makes the equation a true statement. Next, a blank equation is one that is true for some values of the variable and false for others. What type of an equation is true for some values and false for others? That is a conditional equation. A blank equation that is true for all values of the variables for which the expressions in the equations are defined. What type of an equation is that? That is an identity. Number 6, a blank is an equation that is false for all values of the variable. Remember, those were called contradictions. Number 7, a blank equation is an equation in which each term contains a rational expression. I don't know that so much each term contains a rational expression, but you have at least one rational expression in there. We call those types of equations, well, rational equations. Number 8, if an equation has no solution, then the solution set is the blank set and is denoted by what? If you have no solution, the solution set is called the empty set and is denoted by our little brackets that denote a set with nothing in there, the empty set. Recall another way to denote empty set is that symbol. Okay, we have finished 1.1. Now it is time for you to log on to your Connect Math and complete that homework. Good luck!